Good morning. Today we're going to talk about factoring difference of squares. Alright, we're on page 2 of your notes packet. So difference of squares, there's two things I want you to think about. Difference of means to subtract. And then squares, we're talking about perfect squares like 25, 36, 49. All those are perfect squares. Why? Because there's two numbers that you can multiply that are the same that goes into them. For example, 25 is a perfect square because 5 times 5 is 25. 49 because 7 times 7. So all those are perfect squares. So when we're talking about factoring difference of squares, they have to be a perfect square and it has to be subtracting. Now, I have 4 things here that I want you to write down. Somewhere in your packet, write it down. I'm going to move out the way so you can do so. Steps to factoring. Number 1, you always have to check for a GCF first. If there is one, you need to pull it out. Number 2, you got to have a negative sign. If there's not a negative sign, then it is not a difference of squares. Number 3, you're going to check for monomials to be a perfect square monomial. So the number, not only numerically you have to check for a perfect square, but also exponents. It's got to be exponents of 2. So x squared, x to the 4th, x to the 8th, things like that, x to the 6th. Have to be perfect squares. And then number 4, you're going to pull out the perfect squares into 2 sets of parentheses that multiply each other. Why? Well, because just like the numerical part of perfect squares, 5 times 5 gives you 25. So you have to multiply them in order to be able to get that perfect square. So let's look at number 7. Okay, number 7, you have x squared minus 81. So are they perfect squares? Yes. Yes. Is it difference of? Yes. Is there a GCF? No. So now I'm going to do 2 parentheses because x squared, the square root of x squared is x. So I'll put x on both of them. So again, this is like saying x times x. And then 81 is like saying 9 times 9. So I'll put a 9 here and a 9 here. Now, in order for it to be a negative 81, and let's keep this in mind, in order to be negative 81, one of your 9s has to be positive and the other one has to be negative. So we'll make the first one positive and the second one negative. Ta-da, you're done. So x plus 9 times x minus 9 will give you this x squared minus 81. When we get to class, ask me, how does that work? Let's try number 8. A squared minus 25b squared. There is no GCF. We do have perfect squares, so let's factor it out. Start with 2 parentheses. So a squared is like saying a times a. So I have a and a here. 25 is like saying 5 times 5. And b squared is like saying b times b. So I'm going to put a 5b here, and I'm going to put a 5b here. 5b, 5b. And again, in order for it to be negative 25, one of your 5s has to be negative, the other one has to be positive. So we'll make this one positive and this one negative. And it does not matter the order that you put in positive and negative. Number 9, let's try it. See, there's a GCF first. Does 5 go to 45? Yep. Also notice that there's an M and N, okay, in both of them. So let's see if there's a GCF here. So you have 5 goes into it. You have 1 M and 1 N that we can pull out. Let's see what we have left. You have 5 goes into 45 9 times. You took out 1 M, so you have 2 left. You took out the N. Minus 5mn goes into all of that 1 time. Now, let's see if there's perfect squares. That's a perfect square, and guess what? 1 is a perfect square also. So let's finish it. I have 5mn is my GCF, and I'm going to have 2 parentheses. 9 is 3 times 3. M squared is M times M. 1 is 1 times 1. And again, in order for it to be negative 1, one has to be positive, one has to be negative. I'll make this one negative and I'll make this one positive. So in this case, we had a GCF to take out. That's okay. Take it out first. And then what's left over, notice it's a perfect square. It's a difference of squares. And so we broke that up also. Number 10, which is our last one. 98x minus 8x to the third. So the key here is their GCF. I want you to try this one on your own. So try it on your own. Look for a GCF first, pull it out, and then let's see what you have left and find out if those are difference of squares. I'm pretty sure they are, and I want you to go for it. When you come to class, we're going to go over number 10.